This starts our chapter on what are called polynomials, and polynomials is one of my favorite chapters out of all algebra because it's really the building blocks for what's to come when we graph more advanced equations rather than the basic linears. There are lots of other types of graphs that exist in mathematics, and this is kind of the foundation for those graphs. But before we get into polynomials, there are two things I have to make sure that you remember. The first is a number in front of a variable is called a coefficient. And if there are no numbers in front of the variable, then 1 is the understood coefficient. So now we talk about the most basic polynomial, which is called a monomial. And there are three types of monomials. You can just have a simple number, like 5 or -1/3. Numbers are considered monomials when you're talking about the polynomial universe. You can have variable terms, like you could have just x, you could have y squared, you could have x squared y to the fourth. You can have lots of different relationships between these variables, but variables put together is also a type of monomial. Or you could have a product of numbers and variables. So you could have 5x, or you could have -1/3 x squared, or you could have -2x squared y. So those are different ways you can have a monomial. There are three things that disqualify you from being a monomial. First is that you cannot have a decimal as your exponent. We talked about decimal and fractional exponents back in chapter 6. Some of those would be examples of things that are monomials, and some of those are things that would not be monomials based on what the exponent is. If there's a variable in the denominator, which we know would be a negative exponent, then that also disqualifies something. So you can't have a negative exponent, you can't have a decimal exponent. It's got to be greater than 0 and an integer. And you also can't have a variable in the exponent itself. And again, those are things we looked at back in chapter 6. So some of those were examples of things that are not monomials. There's something about a monomial that we'll talk about in a moment, and that's called the degree. And the degree of a monomial is the sum of the exponents of the variables. So for example, let's look at these ones up here. I'll start with the ones that have variables, so I'll start with C, then go to B, then go to A. The degree here would be 3 because 2 plus 1 is 3. The degree here would be 2 because the exponent is 2. The degree here would be 1 because the exponent is 1. So if there's just an exponent, then that's it. Or if there's just one variable, that's the exponent. If there's more than one variable, then you would add up the exponents. Over here, the degree would be 6. Here the degree is 2, and here the degree is 1. Now, when you get to numbers, the degree is related to the variable. Since these have no variables, then the degree is 0. So numbers, or just constants as we call them, have a degree of 0. So I'd like you to pause the video and try finding the degree of these monomials. All right, hopefully you did well. Just be careful. Remember, constants have a degree of 0. This would have an exponent of 1. For here, you add up the exponents, and you'd add the exponents here as well. So now, if you have more than just a monomial, which is what we'll mostly encounter, you have this thing called a polynomial. And if you think back to roots and prefixes, poly means many, and then there are pieces of a polynomial, which we'll talk about, and each monomial within the polynomial is called a term. So this polynomial has two terms, one here and one here, and it's called a binomial. Bi means two, roots and prefixes. This would be an example of a trinomial because there are 3 terms. Tri means 3. Anything after 3 we usually just call polynomial. You could call it a quadnomial, but no one would ever call it that, and they would probably look at you really confused. You can also have degree of a polynomial. For degree of a polynomial, you would just take the biggest term. So, for example, here the degree is 1 and here the degree is 0, so the degree of this polynomial would be 1. For this second trinomial, here the degree is 2, 1, and 0, so since this has the biggest exponent term, or the biggest degree, then the degree of that polynomial is 2. When your polynomial is written so that the exponents go from greatest to smallest, then you have this thing called standard form. Typically, we like to have things in standard form. It's kind of like simplifying for fractions. When it's in standard form, you can look and talk about your polynomial compared to somebody else's polynomial, and you don't have to worry about your terms being in different orders. So preferred order is standard form. Let's practice putting things in standard form and looking at the degree and what we would call it. So this first letter A has only one term, so it can't really be ordered in any particular way, so it's just 3z to the fourth. The degree would be 4 because that's the highest exponent, and it would be a monomial. Letter B is not in standard form because, see, here's the highest exponent and here's the lowest exponent. So let's rewrite it. The first would be 5x squared. Then would come minus x. Then would come plus 4. Remember, the sign has to travel with the number. The degree here would be 2 because this term right here has the highest degree. And this has 3 terms, so it would be a trinomial. And letter C, the q to the fifth should be first. So that's q to the fifth plus 8q. This piece right here has the highest degree, so its degree total would be 5. And this would be considered a binomial because there are 2 terms. Let's look at one example of using a polynomial in a realistic situation. And most of the polynomials that you'll deal with from now going forward will be setting you up for your future courses in physics and science classes, because a lot of things in real life model polynomials, and physics is all about studying things that happen in real life. So we've got this polynomial expression, very crazy looking, but don't worry, I'll take care of you. And it represents the height of an object, where this piece right here is the initial vertical velocity. This piece right here is the initial height, and t is time. So I've got v0 is the initial vertical velocity, s0 is the initial height, and t is time. So all I have to do is plug in the pieces, write a polynomial that represents the height of the baseball. So if this is the information in the story, then all I have to do is take this and plug it into my polynomial wherever I see them. So let's plug in what we have. Negative 16, I don't know the time, so I'm just going to leave that as t squared, plus v sub 0 is 30, t, plus s sub 0 is 4. And that's the answer because I don't know what t is. Now, just for practice, what would this be called? A trinomial, and you can see it's also written in standard form. So now they tell us the height after 1 second. So now I can plug in t in this polynomial and get an actual numerical answer. I can find the height, which in this case would be in feet. So negative 16 times 1 squared plus 30 times 1 plus 4. That's going to be negative 16. You got to follow your order of operations. And that is negative 16 plus 30 plus 4. So that's going to be 14 plus 4, which would be 18, and the label is feet. So if this girl right here is throwing up this baseball, and this is her initial speed, and this is the initial height of the baseball, then after 1 second, the baseball will be 18 feet high. And you can plug in all different values of t, and you can figure out how high the baseball is after 2 seconds, or 3 seconds, or a minute, or how long it takes until it lands back on the ground. That's lots of things that you can do with polynomials. If you have any questions, write them down and ask me when you come to class.